Okay, so for this question, the explanation of this question, there are two ways of doing it. In my answer key, I reflected the algebra way. There is a geometrical property way of doing it. So I'm going to explain both ways. Okay, so first of all, before I explain both methods, I'm going to explain the phrasing first. Some of you might have an issue with understanding this phrasing. So when we say that D is equidistance from A, B, C, the word equidistance means same distance. So D is same distance from A. That means AD. And D is also same distance from B. That is BD. Okay, and D is also same distance from C. So that is CD. So essentially, they are trying to tell you that these three lengths are the same. So these three lengths are the same. So since these three lengths are the same, then we can deduce that D is center with radius AD, or you can, of course, you can say BD, or you can say CD. So because of this, right, you can see as this is a center of a circle. Okay, you can say that since these three lengths are the same, D is the center. And because if this is the center, right, you can imagine by this property, it's not very nice, hang on. So by this property where angle in a semicircle. So which means, right, okay, if because of these three lengths, they are the same, D is the center of a circle. And B, so, okay, a bit messy. So which means, right, this part, there are two radius here. There are two radius. AD and DC are the two radius. So essentially, two radius will form a diameter. Okay, so since the three lengths are the same, D is the center of a circle with these three as a radius. Therefore, AC is equal to the diameter. And by the property, by the converse of angle in a semicircle, I will get this as a 90 degree. Okay, so if you see it as a center, then you can see that two radius make up a diameter, and it fulfills the property of angle in a semicircle. That's why ABC turns out to be a 90 degree. So if you explain this, right, you will get your 2 marks. Okay, you must explain the property. What is the property? You must mention angle in a semicircle. Okay, so this one is the non-algebra way, is explanation by the property way. Okay, so for some of you, you might be able to explain it in a more algebra way. So if you didn't come to you about this property, you approach it like algebra, because some of you got A math doing geometry background. So you might approach it in this way. Okay, so how we approach it in this way, right? So if I want to assign algebra, then I will assign the algebra here as X. So I will start off with ADBBX. And then because we got all the same length, we got isosceles triangle. So we will be making use of isosceles triangle. I'll be trying to do an isosceles triangle in ADB. Okay, so in triangle ABD, okay, I know that it's isosceles already. Okay, because of this part. Okay, so it actually formed two isosceles triangle. So in the first one, I can find both angle. So I'm going to go ahead and find both angle. So if I find both angle, okay, it will be 180 minus x divided by 2. So each of the angle here will be 180 minus x divided by 2. Okay, then I'm going to go on to the next isosceles triangle. So this part will be angle on a straight line. So because of the x, right, I will get an angle on a straight line. So do explain your angle on a straight line. And then because it's an isosceles triangle, you can find these two angles. Okay, so let me charge a bit. I didn't know my pencil is a bit low on battery. Okay, so after this, I'm going to find these two angles. DBC is equal to DCB. It will be 180 subtracting this one and divide by 2. So if you work out the algebra, the 180 will nicely cancel out. You're actually left with an x over 2. So each of this one is x over 2. This is x over 2. Now we can try to find out our ABC. We can try to find out our ABC. So if you look carefully, ABC will be 180. So you just try to add up the two fraction, the two angle in fraction. So when you try adding up the two fraction, the two angles in fraction, same denominator, you will find that you got 180 divided by 2, which is exactly 90. So if you prove by the algebra method without any property, that's fine, because you work out to get the value. That means you use an unknown and you actually calculated out a 90 degree. So that's fine. Okay. Or subsequently, you can use the angle in a semicircle to justify the 90 degree. So this will be the two methods.